We Earthlings have fired numerous probes and satellites towards the Red Planet. An invasion of sorts, not for conquest, but for knowledge. What happened to Mars? Is there or has there ever been life on the planet?
A fundamental question that needs to be answered is life as we know it on Earth, even the simplest type of microbial life, unique? If we were to go to Mars and we were to find evidence of early microbial life, or maybe even present life that somehow survived in the near surface, would it be the same as the early life that developed on Earth? That's a very fundamental question. Does life emerge generally in planets where the conditions for life are favorable, if we find out that they were favorable on Mars? Or might life take its own unique path in different environments and turn out differently?
We have bombarded Mars with satellites and landers, but there have been more failures than successes. The Soviets established 2 Mars orbiters, while NASA landed 2 Viking landers carrying complex analytical laboratories and searched for signs of microbial life. Their findings were inconclusive. Further missions to Mars still had a high mortality rate, but the successes were outstanding, with robotic probes operating for years beyond their initial missions. In fact, Mars is a planet occupied solely by robots on the surface and satellites peering down from above. All these instruments perform admirably in their specified fields of endeavor, giving us a much clearer picture of the planet and its history. The science was following the water, what happened to it, and where it is now.
Thanks to the specific instrumentation on board the mission, we are able to tell us what kind of ice did we find. And the result is that there is a mix of CO2 ice, or carbon dioxide ice, and water ice. And it's very important to characterize it, especially for the water ice or frozen water, because one of the main objectives of any mission to Mars is to trace the water on Mars in every form, liquid if possible, solid, water vapor. So it's very important to study the ice because it's one of the reservoirs of water on the planet.
The science was conclusive. There was water on Mars. There were ancient lakes and rivers, even an ocean. We needed to learn more. With the advancement of analytical technology, computer power and robotics, a new rover was constructed. Big, complex and heavy, it required a new way to land on Mars safely. Engineers came up with a system that couldn't be fully tested here on Earth. It required a lot of things to happen correctly, on time and in order. This was the Sky Crane, and the rover Curiosity was the first to try it out. A controlled re-entry with heat shield, aerobraking with a parachute, all pretty standard. Then a rocket-powered Sky Crane drops from the aeroshell and gently descends toward the surface, spooling out the rover below on cables. The rover touches down, cuts the cables, and releases the Sky Crane to fly off and crash harmlessly. The Curiosity rover has been an astounding success, traversing the terrain for over 10 years, taking samples, drilling and studying rock formations, zapping samples with a powerful laser, and photographing its progress.
Now, in the belly of that rover is an instrument called SAM. It's an instrument suite that has a couple different instruments in it that allow us to look at different types of gases. It helps us understand the chemical composition of the atmosphere and the end of minerals that might be found in the rocks and the soils on the surface. In particular, it helps us identify organic molecules that might be present.
So the sorts of evidence we're looking for, sorts of signatures of past life that we would be looking for would be signatures of microbial life. So not realistically looking for dinosaur bones and that kind of thing. If life ever existed on Mars, we expect it to have been microbial, microorganisms.